Last new lesson of the year.
Woo! Yeah. Yes.
Oh, okay. Last hour was like way more enthusiastic, but okay. All right, I get it. I get it. You love it in here. You love it. You're gonna be sad. So today we're gonna talk about an application of these exponential equations, and we're talking about interest, making cash money. Okay. So here we have two formulas that we're going to use. One is the compound interest formula, and this is going to include the principal, which is the amount that you invest, and the R is the interest rate as a decimal, and then a little twist that you haven't seen yet. Since it's compounded in different increments or time frames, we have a variable for that. So the N is going to be the number of times that it's compounded. And this says per unit T, but really we usually use that in years. So it's going to be however many times that interest is compounded per year. So you might have some different terms that you have to interpret, like let's say we have quarterly. How many times a year would it be if it was compounded quarterly? Four, good. How many times if it was compounded annually? One. Semi-annually. That's a hard one. Two. Biannually. Same thing, too. What if it was compounded daily? 365. What if it was compounded, this is in terms of years, right? What if it was compounded monthly? 12. Good. So the N part will change based on how many times it's compounded in a year. Okay? So let's get cracking. By the way, I'll give you these formulas on the quiz, so you don't have to memorize the formulas. So here we go. We have $5,000. Yeah, final two. $5,000 invested at 1.3%, compounded quarterly. How much money will be in the account after 5 years and 20 years? So compounded quarterly means that N is 4. $5,000 invested, that is the P. 1.3%, that's going to be the R, but it's going to be 0.013 because it has a decimal. So, matter of putting this down on paper and then using a calculator to evaluate what we have. So we have 5,000 times 1 plus 0.013 divided by N, which is 4, and that's going to be to the 4 times 5 power. So it kind of makes a little more sense when we talk about a specific example. Like if we're compounding quarterly and we do that for 5 years, how many times did we calculate the interest? We did it 4 times a year for 5 years. 20, right? So there was 20 times. So after the first quarter of a year, we said, boom, here's some interest. And then after the next quarter, which is 3 months, we said, boom, here's some more interest. And then we said, boom, here's some more. And we did that 20 times over 5 years. And at the end, you end up with more money than you invested. So take your calculator, and actually part of the lesson is typing this ugly stuff in the calculator and being able to get the right answer. So part of you being in the class right now and participating is making sure you can do that on the calculator. So I'll give you a few minutes to get situated, and then we'll get an answer. Okay, we got some answers here. We got 5,335, right, Aaron? 0.23. And that's a dollar bill, y'all. Yay? If you didn't get that, figure out what's going on. That's your job now. You're like, wait, I couldn't get it right in the calculator. What happened? Do the same thing for 20 years. So same exact formula. It's just that now instead of 5, I'm going to put it in for 20. So it's going to be 4 times 20 years. So compounded quarterly for 20 years is going to be 80 times they calculated interest and gave me more money. So I'm going for much more time now, so I should have more money. What do you get for that one? I think it's like 6,000 something. 6,481.92, 92 cents. That sounds right. Anybody confirm that? Yeah. Okay. There you go. Number 2. Now we're going to solve for a different variable. It says how long will it take an investment of $200 to go to 250? So how long means we're going to be solving for what? T. So the how long will it take means that we don't know what T is. So let's solve for T. Alrighty then. We have 250 is our amount after we invested $200 at an interest rate of 1 plus 0.042 over the number of times it is compounded is monthly, so that's 12 this time, to the 12t power. Um, 4.2% as a decimal is 0.042. So writing percents in decimals, right? What's 50%? If you kind of forget, do the easiest one you know. What's 50% as a decimal? 0.5, right? So basically what you do is you take the decimal at 50%, which is right there, and you move it 2 to the left. 0.5. So like right here, 4.2%, if I move that 2 to the left, now I have 0.04. Wait, 2 to the left is going to be right there. So it's right there. So anyway. All right, so you solve that for t. So now the first thing I'm going to do is I'm going to divide both sides by 200. Whoop. Need to get a pen to do that. So I have 250 over 200. I'm using a calculator, so I'm just going to, I kind of have a tendency to just leave that, but you could change that to 25 over 20, which is, I mean, if you wanted, it makes a decimal of 1.25. So you could do that, but I just leave it as a fraction just because I'm using a calculator anyway. So, and also if I chop off the decimal and I chop a little bit of the decimal off, then it's going to be less accurate. So since you're using a calculator, just leave it as a fraction like that. And over here, I'm going to have 1 plus all this stuff. Whoa, too many zeros there, Mr. B. Oh, great. We got this stupid thing going now. Over n, which is 12. Is that the Zamboni? There's Zamboni in the hallway. Now, how do we solve for an exponent? If it's the variables in the exponent, what do we do? Well, if we did reciprocal, it would be 1 over 12t, and then it wouldn't really, I'd have then the same thing on the other side. I'd have 1 over 12t. It wouldn't, Lillian? Log? Perfect, log. So log it. Write it as a log. This ends up kind of being a crusty looking log base because the base of the log is like 1 plus 0.042 over 12. And then I'm taking the log of 250 200ths, or if you changed it, 1.25. And that equals 12t. It's crazy. So how do you get rid of t? Yeah, if it's times by 12, you got to divide by it. So divide both sides by 12. And so I take all that stuff over there, I divide it by 12. So t equals all of this stuff. Could you do the log first in the calculator, hit enter, and then hit enter divided by 12? You could do that, yeah. Yep, I think it ends up being, is it like 5.5, 5.32? Another question. Couldn't you just solve for the base? Hmm. So you're saying you want to simplify this part in here? You can, but you don't have to because you're using a calculator. Or simplify that stuff? You can, but you don't have to because you're using a calculator. And if you do simplify that and chop it off, and you chop off some of the decimal part, you truncate the decimal part, then, and you make another, yeah, I know it's a fancy word. If you chop off part of the decimal and you round it, then when you make a subsequent calculation, you're basing that next calculation on a estimated value, and then your answer becomes, it has like a compound error in it. Like it's not as accurate. So that's why I just would leave this as in here. I just leave this stuff in here as a fraction because I'm putting it in the calculator anyway. So, but all right. Oh, kind of a fun question here. Let's see if you can get this one. Yep. Plug it in. I'm going to pause it here. You guys can work on this for a minute. So this fun little question here says, hey, invest $1 at 100% interest for 1 year compounded annually, we determined. And so when you end up doing the calculation on this, which is this kind of common sense one, and you'll probably see you get A equals $1 times 1 plus 1 over 1 to the 1 times, what is it? 1 times 1 power. Weird. So that means you have 1 times 2 to the 1 power, which is $2. I made $2. Yeah, I invested $1. I invested $1 at 100% interest, and I got $1 back. I made $2. Okay. Next question. Next page. Here we have compounded continuously. So the interest is compounded continuously. It's always compounding. Okay. Well, here we are going to use the mathematical constant E for this. This is also known as PERT. Okay, so the amount you invested, P, principal, times E to the RT. All right, so this is compounded continuously. So here we go. We have a situation where the amount is 2,000. We're going to invest it for 10 years, or we invested for 10 years and we ended up with 2,000 because they give us the A. Don't goof this up like I did second hour and put 2,000 as the P. It's not, it's the A. Question. It has to tell you, yeah. Otherwise you don't know what to do. So this one says compounded continuously, so I'm going to use my PERT formula, but it gives me 2,000 for my A, so now I'm solving for my P. So this is 2,000 equals P E to the RT, so R is 0.032 for 10 years. E is on the calculator. Oh yeah, E is approximately 2.71. It's kind of like pi, you know. So here's an application of E. So the thing is here that this E to the whatever power, this is just a number. That's a numeric value right there. That's like some number P. So how do you get rid of something times a number? What do you do if it's times a number? Divide. Good. So we have to take both sides and divide by E to the 0.032 times 10 power. So what? Because that's like a number, so that stuff cancels out. So my value is E. My value is 2,000 divided by E to the whatever that is. What was your question?
Can I just do e to that stuff, and then whatever I get, do that times p, and then divide by that? That's what I do. You know what I'm talking? I don't know. Yeah, you like solve e first, and then so I did this. Look, by your answer that you got 60. I did like that's for my e. I got 1.38.
Oh, you're rounding again. You're getting 1.38. You're rounding it again.
So how many should I go out?
On my calculator, when I do this on my calculator, I think this is the best way to do it. You type in, you hit the button 2, 0, 0, 0, divide, right? And then you might want to use a parenthesis here because you have TI-30X, so it's not the fanciest one. You can't just create like a fraction like in the Inspire. And then you hit the E to the X button, and so that would be E to the power of, and then it's going to have that, and then you might want to put in parentheses there 0.032 times 10 parenthesis. That's why the TI Inspires are kind of nice because you don't have to, the way you write it out is like the way you type it in because you can do a blank fraction. But otherwise, you got to get the parentheses going there. So now you should get an answer of, what did we get? Okay, I'll calculate it. Got some whining going on in here. Okay, so we're back. So we had a student who they were off a little bit, just a tiny little bit different, right, than mine. And I typed my whole thing. I typed this whole thing in the calculator and I hit enter one time. And the difference between my answer and what did you end up with your answer? 1449 what? 0.28. So I'd say that's significant. That's $3 off. Okay. So yours was $3.02 off because what you did was when you calculated it, you took the E to the whatever stuff and you made that 1.38, right? So what happened was you rounded off a bunch of stuff that was after the 0.38 and you chopped that off and then you made another calculation and then therefore your answer is $3 off. So not the best answer. An answer that's close, but not depends on your accuracy. Lillian.
So if you were to actually take exactly what e was and then divide 2,000 by the exact number instead of rounding, is that work? So if you figure out what e to the whatever power is first, and then put the exact answer by 2,000 by the exact.
Yeah, the problem is if you find what e to the 0.032 times 10 power is exactly, well, really, so you would have to like carry it out to however many decimal places your calculator does. And so then you end up having to do like whatever it is, like 12 decimal places, and it just ends up being more work to write all those down from the calculator than it does just to calculate it all in one big calculation. But the more decimal places you go after, like Aaron chopped hers off at 1.38 like that, maybe if you went to like 1.38 blah 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 and did like 8 decimal places, then your answer wouldn't have been $3 off. It might have been 3 cents off or something like that, you know? So, I mean, it's just kind of it's an accuracy thing. Does that answer your question good enough? Kind of? All right, moving on. Last slide of the year. Aw, so sad. Last hour we had a moment of silence for the last slide of the year. We have 5 minutes. Okay, so this one here is going to be solving for t. So we're going to have to use a log. So 7,000 is my A. It's the amount after, equals 5,000. That's the amount I invested. That's the principal, times e to the RT. That's going to be 0.035 t. So I'm solving for t here now. Okay. My variable is there, so it's part of this stuff. And so I'm multiplying by 5,000 by that, so I'm going to take both sides. I'm going to divide by 5,000. Get rid of that first. And what I have left now is e to the 0.035 t equals. Now, this one, I can see that this kind of reduces, so I'm just going to make this 7/5. You all right with that? Because 7,000, 5,000 is the same as 7/5. So it saves me from typing 6 zeros. But it doesn't really matter if you do that, but I'm going to use that this time. Okay, that's called the Dave factor. Yep. Now I want to get that t down from exponent land. It's like way up there. It's like, hey, get down from exponent land up there. Okay, so how do we get that down from exponent land? How do we solve for a variable that's exponent? Logs. Yep, throw a log at it. Okay, get that exponent down there, throw a log at it. So we rewrite this as a log, but guess what? It's e. Its base is e, so I'm going to use what kind of log? The natural log. Yes, natural log. So I'll go natural log. It has a base of e already, so you don't have to type in e. Some people were typing e in their calculator and it was goofing them up. You don't have to. If you type natural log, it's implied that the base is e. So natural log of 7/5 is equal to 0.35, not 0.35, 0.035. 0.035 t. Now what? I got to get rid of the 0.035, so I divide both sides by 0.035. So the natural log divided by 0. Crime in Italy. I'm rushing now because we're getting close to low on time. 35. Okay, and that's going to cross those off, and that's going to give you your t value. So what do you get when you put that in for t? Take the natural log of 7/5, and you could do this. You could go natural log 7/5, and you could hit enter, and then you could divide that by 0.035 and hit enter, and that would be exactly as accurate as the calculator works as well. You know, or you could do it all in one calculation too. Make sense? So what did we get? Anybody get an answer for that? The natural log of 7/5. I get 0.3 whatever, and then divide that by 0.035. 9.61, I got that too. 9.61 what? Bananas, apples, oranges, Bolios. 9.61 Bolios, oh my. Years. 9.61 years. It's been real with you guys. Okay, it's been a wild ride. Okay, you've learned a lot this year. You forgot a lot this year, and now you're gonna have to remember a lot coming up in the next couple weeks for the big final exam. Godspeed. Under 25 minutes. Go.